Okay, today we are going to review from geometry about two special right triangles. One, hopefully you remembered as a 30, 60, 90. And then the other is the 45, 45, 90. So we'll look at that next. So let's just start with our 30, 60, 90. So I'm going to draw a right triangle with approximately those angles. Okay? So this is 30, that's our 90, this is our 60. And there's a few ways that you may have learned this back in geometry. The side opposite 30 was referenced as x. The side opposite 60 is x radical 3. The side opposite 90 was your 2x. Okay? Your teacher also could have just called it, instead of those, they could have just put in numbers, okay? And it won't let me write over it, but they may have also just said, okay, this side is 1, this side is root 3, and this side is 2. And you could have used either one of these diagrams to solve for missing pieces. If you knew the side opposite 30 was 2, therefore x equaled 2, and you could plug in 2 everywhere to get the rest of the missing sides. If you didn't use x and you use this over here, that means you would have just set up a proportion, because any 30, 60, 90 triangle follows this ratio, okay? And what's important here is we're going to place this 30, 60, 90 triangle into our unit circle. Okay, so remember our unit circle. It is a circle of radius 1. So remember how I talked about it last week. It's zoomed in. So don't forget that your radius here is 1. So when we take that special right triangle from up above that we already drew out, I'm going to fit it right here in our first quadrant, okay? So I'm going to take that triangle that I drew, your 30, 60, 90, and I'm going to put it right here. Okay, so here's my right angle, here's my 30, here's my 60, okay? The important angle here is that central angle is 30 degrees. So we saw up above, I'm going to just draw this off to the side, that the side opposite 30 was our x, the side opposite 60 was our x radical 3, and the side opposite 90 was 2x, okay? Or we saw it as x 1 and 1 root 3. Okay, I'm going to keep the x's in here. Well, we know here that our radius is always, always, always 1, right? So if we set this equal to 1, what does x have to equal if you solve that? 1/2. So that's your side opposite 30. And then your side opposite 60, since x equals 1/2, it's 1/2 root 3. And when you write 1/2 root 3, that's the same thing as root 3 over 2. Okay? Something that's important to remember, the side opposite 30 is your smaller side. The side opposite 60 is your medium side. And your side opposite 90 is your largest, 'cause that's your largest angle. So if you did plug in to your calculator root 3 divided by 2, you're going to see it's like 0.86 something. So obviously that is between 0.5 and 1. So when we talk about this coordinate on the unit circle, and that's the important part, and this is where your unit circle is so important, is knowing that coordinate. So remember, again, this is zoomed in. So we're going right about 0.86, which is root 3 over 2, and then we're going up 0.5, okay, or 1/2. So that's your coordinate right there, okay? That coordinate is very important, and that's going to be those are going to be values that you'll know once you learn your unit circle and practice it enough. And like you learned last week on the Desmos, root 3 over 2 is your cosine of 30. 1/2 is your sine of 30, because your cosine corresponds with your horizontal distance, your sine value corresponds with your vertical distance, your up and down. So now what we're going to do is we're going to figure out this ordered pair, this ordered pair, and this ordered pair using that exact same triangle, just by reflecting. So picture that triangle right there, okay? And we are going to flip it over the y-axis. Well, guess what? It's now over here. Okay, this angle is still 30 degrees. This is still 90. And then the top angle is 60. So again, if our radius is 1, your side opposite 30 is your smaller side, which is 1/2, and your side opposite 60 is your root 3 over 2. But now you have to be careful here, because from the origin, you're now going left. So what's going to be true about the sign of the root 3 over 2? It's going to be negative. Positive 1/2 because you're still going up. Okay, I'm going to flip it again. Now I'm going to flip it over the x-axis from there. So now that right triangle is right here. Okay, so again, this is that 30-degree angle, central angle right there. Side opposite 30 is going to be your smaller side. Side opposite 60 is going to be your larger side. So we're going left root 3 over 2, so that's negative. But now we're going down 1/2, so now we have to say that we're going in the negative direction. So you have to include that negative sign, okay? And probably by this point, you can figure out this ordered pair without even drawing the reflection of that triangle, okay? If you can, go for it. If you need to, you can picture that original right triangle just reflected down. And notice how my right angles, you guys, are always on the x-axis, always drawn like that. This is your smaller, so that's your 30. This is your 60. We're going right root 3 over 2, so still positive. And now you're going down 1/2, so that's where the negative comes in, okay? Now, using this same triangle, we can come up with the ordered pairs of 60 degrees, okay? So take that triangle, and instead of having it written this way, have it written like this, where your 60 is here and your 30 is up here. Hypotenuse is still 1. Side opposite 30 is still your smaller side. Side opposite 60 is the middle side, okay? I'm going to draw it up here in blue just so you can see it a little bit different. Okay, and that's this right triangle. So now that central angle here is 60. That's the larger of the two acute angles, right? 60 is larger than 30. So opposite that is going to be the larger side. So that's why now we're going up root 3 over 2. So that's your y value, which means you're going right 1/2. Notice all that happened there with your coordinates. They flip-flopped. Why? Because we flipped which angle was on the inside, okay? Originally it was the 30, and now it's the 60. So you're just flip-flopping those sides. The hypotenuse had to stay there because that's your radius. Remember, your radius is always 1. So now you can flip that across your y-axis and come up with this coordinate, across your x-axis and come up with that coordinate, and across your y again, or go back to the original and flip down here. So you should be able to do that without drawing your triangles, okay? So what I want you to do is, I'm actually going to stop the video here, just so it doesn't become too long, and we're going to pick up with this, and I want to see when you go open up video number 2 of the day, that those ordered pairs are already filled out. See if you can figure out what those coordinates should be based on what your coordinates were for the ones in red, okay?